So this is the last problem of chapter 3. It is number 55 of the review problems, and this one is on page 170. And it's a word problem. It's an application of the concepts of this chapter to the issue of pollution. So this is the prompt. In one province of a developing nation, water pollution is analyzed using a supply and demand model. The environmental supply equation, so this is again number 55. So we have a supply equation is represented by L equals 0.0183 minus 0.0042 over P. So this describes the levy per ton, L in dollars, as a function of total pollution in tons per square kilometer for P is greater than or equal to 0.2295. And the environmental demand equation is going to be L equals 0.0005 plus 0.0378 over P. And this describes the per ton abatement cost as a function of total pollution for P greater than 0. Find the expected equilibrium level of total pollution to 2 decimal places. So basically what we have here is, context aside, we have a supply and demand set of equations which represent the basic sort of market model. And one important thing to understand here is that the L represents a quantity, and quantity is a function of price. Now, normally in economics, in at least the introductory courses that some of you may have taken, usually we have price on the y-axis and quantity on the x-axis, and price is a function of quantity. In reality, though, quantity is actually a function of price. And so whenever we express quantity as a function of price in an equation, we basically can use the normal terms of a supply equation or supply function and a demand equation or demand function. But if we are presented with these equations with the variable P as the dependent variable, and that being as a function of quantity, then which reflects sort of like the standard market model setup that you have seen graphically. In those cases, we term the equations the inverse demand function and the inverse supply function. So that's just something to keep in mind if you're going to be moving towards intermediate microeconomics. It's an important distinction that just applies to like sort of mathematical applications to market models. So just be sensitive to that sort of distinction. That won't really come into play in this class much, but it will in the future. So right here, what we essentially have, like a context aside, all the complexities of what this all means aside, we essentially have 2 equations with 2 variables, and we just need to solve for one of the variables. So why don't we solve for we need to solve for one of the variables and then plug that value into one of the equations and solve for the second variable by substitution. So because both equations are solved for L, we can then set the equations equal to each other, solve for P, and once we get the P value, we can plug that into one of the equations and solve for L. So let's set these equal to each other. So 0, let me get it into the camera. There it is. 0.0183 minus 0.0042 over P is going to equal 0.0005 plus 0.0378 over P. So let's get the p's on the numerator. So let's just multiply everything by p. So we're going to have p times 0.0183 minus 0.0042 equals 0.0005p plus 0.0378p. Oh, sorry, the p's cancel out in this term. So again, a long expression, and there it is. I got it in the shot. Okay, so now let's get the p's on one side and the numbers and the terms without the variable on the other. So let's add, so I'm not going to show the step, but I'm basically adding this term to both sides, and I'm going to subtract this term from both sides. Okay, so we're going to have p 0.0183 minus 0.0005p equals 0.0378 plus 0.0042. All right. So I'm just going to use my calculator here because I don't want to do this math by hand, nor in my mind, because I'm being lazy. 0.0005 equals, so on this side we're going to get p times 0.0178 equals 0.0378 plus 0.0042. We're going to get 0.042 on the right hand side. Then we're going to divide both sides by 0.0178. And thus the p we are looking for is going to equal 0.042 divided by 0.0178. I'm just gonna, so it's 2.3595 blah blah blah. It's an irrational number, a non-terminating decimal. So I'm just going to leave it at 2 decimal places, so it's going to be 2.36. I'm going to round up. And now that I have the price, I'm going to choose, let's choose the supply equation, which is L equals 0.0183 minus 0.0042. We're going to plug in for P 2.36. So L is going to equal 0.0183 minus 0.0042 divided by 2.36. 0.00178, let's say. So then L is going to equal 0.00183 minus 0.00178. So it's going to equal 0.0165, and it said find the equilibrium level of total pollution to 2 decimal places. So let's round up here to 0.02 for L. So L is 0.02 and P equals 2.36. And that is the solution to this problem. So, I mean, it's a standard like set of equations that you need to solve for 2 variables. It's just the numbers are a little bit more complicated, so you just, in a problem like this, just be very careful when you're doing the math. But you know the method, and there's the answer.